In the context of 5G aerial combat, the PL-15 air-to-air missile has shown brilliantly. Today, we'll delve into where the PL-15 stands on the international stage. Before discussing the PL-15, let's first explore the components of medium-range air-to-air missiles. Looking at this diagram, medium-range air-to-air missiles consist of 4 parts. The first part is the unspecified component. The second part is its energy supply system. Nowadays, medium-range air-to-air missiles generally use batteries to provide energy for the equipment compartment. The third part is the warhead, and the fourth part is the fuel and its engine components. As the range of medium-range air-to-air missiles continues to increase, they all require mid-course guidance. Therefore, whether it's a command, guided mid-course antenna, or a data, link, guided mid-course antenna, it is usually placed at the tail of the air-to-air missile. The antenna is connected to the front equipment compartment via a cable. This is a photo of a PL-15 I took at the Zhuhai Air Show. You can see that the cable of the PL-15 is connected to the front equipment compartment, and there are 4 long slots here, which are generally radio fuses. After covering the components of medium-range air-to-air missiles, let's move on to the guidance modes of medium-range air-to-air missiles. Currently, most medium-range air-to-air missiles on the market use active seekers for terminal guidance. However, as we know, air-to-air missiles have limited volume, so their seekers can't be made too large, and the detection range of the missile seeker is limited. Thus, air-to-air missiles require mid-course guidance. For example, the AIM-120A, most of the AIM-120C series, and our country's early PL-12 use command correction guidance for mid-course guidance. Although command guidance follows the design process of the homage, too, it's clear that with command guidance, the aircraft needs to constantly track the missile, in addition to tracking the enemy aircraft. Since the detection angle of a fighter jet is limited, medium-range air-to-air missiles using the original command guidance couldn't employ lofted trajectories. To use lofted trajectories, air-to-air missiles need to adopt a data-link approach. We can see that most of the newer medium-range air-to-air missiles now use data-link mid-course guidance. As long as there is an equipped data link on the battlefield, whether it's an aircraft, a ground-based launch platform, or a sea-based launch platform, as long as it has the corresponding data link device, it can guide the air-to-air missile towards the enemy. In this case, air-to-air missiles can use lofted trajectories. After discussing the guidance methods of air-to-air missiles, let's talk about dual pulse. The main mode of dual pulse is that an air-to-air missile has a partition in the middle, enabling 2 ignitions in the air. For air-to-air missiles, their drag varies at different flight speeds. At a flight speed of around 4 Mach, the drag is nearly 3 times that at 1.5 Mach. We also know that air density varies at different altitudes, and different densities result in different drag forces. It's precisely because of the data link mid-course guidance method that dual pulse air missiles have emerged. Through 2 ignitions, the missile can reach a higher altitude. Igniting at high altitude results in lower drag. In this case, not only can the range be significantly increased, but as we can clearly see from the diagram, when attacking a target at the same distance, the speed at which it strikes the target is faster than that of a single pulse air-to-air missile. Air-to-air missiles have basically no power at the terminal phase. For air-to-air missiles, their terminal maneuverability actually relies heavily on kinetic energy. So the higher the terminal speed, the higher the probability of hitting the target. For slow air-to-air missiles, the biggest difficulty isn't actually the partition, it's when to ignite the second pulse. According to domestic papers, the range of dual pulse missiles varies with the interval between ignition times. However, in actual engagements, the targets are different. So for targets at different distances, determining the optimal second ignition time to guide the missile to strike the target along the most optimal path is a real test of the missile's design capability. So, In this diagram, we also see that in the research on key technologies of dual pulse solid rocket motors, it's mentioned that the energy distribution technology for dual pulse missiles is a direction that needs to be overcome. For targets at different distances, the second ignition time of the missile is different, even for suddenly appearing close range targets. The second pulse of the dual pulse missile ignites immediately after the first pulse, and in fact, its range may be less than that of a single pulse missile. In addition to the aforementioned launch mode, other ways to increase the maximum range of air missiles include improving the missile's propellant and materials, which can also extend the maximum range. The third method is the most primitive one, increasing the energy of the air missile. Let's move on to the next topic, the maximum range of the missile. For air missiles, their range varies greatly depending on the altitude and the relative speed of the target. This is clearly shown in this diagram. At a launch altitude of 10 meters, with our aircraft speed at 1.2 Mach and the enemy's altitude also at 10 meters with a speed of 0.9 Mach, the range is in this column. If our launch altitude is 3 kilometers, our aircraft speed is 0.8 Mach. The enemy's altitude is also 3 kilometers. Speed is 0.8 Mach. Flying head on and the target doesn't maneuver, then the range is in this row. So we can see that at different altitudes, the speed of our own aircraft and the speed of the enemy aircraft actually have a great impact on the maximum range. The higher the altitude, the faster our aircraft's speed, and the faster the head on target speed, the greater the range will be. Therefore, some people were concerned about the previous figure of the PL-16, where the PL-12 has a range of only 50 kilometers, and the PL-15 has a range of less than 200 kilometers. In fact, there's no need to be overly concerned because our country's standard for the maximum range of missiles has changed. When our country designed the PL-12, it was mainly to attack the US third generation or fourth generation fighter jets, namely the F-15 and F-16. Ideally, these third and fourth generation fighter jets would launch air missiles at 1.2 Mach. So at that time, the setting was that the head on speed of the enemy target was 1.2 Mach. In this case, the range of the PL-12 could reach 70 kilometers. However, when designing the PL-15, it was mainly to attack the US fifth generation fighter jets, mainly the F-35. After all, for the US, the number of F-22s produced is limited, and the US future fighter jet is the F-35. The F-35 has poor supersonic cruise capability, so when it mostly enters the battlefield, its speed is only 0.9 Mach. Therefore, according to the new target, the standard has changed. The standard is that the battlefield entry altitude is 10 meters, our speed is typically 1.2 Mach, and the enemy target's altitude is 10 meters with a speed of only 0.9 Mach. In this case, the maximum range of the PL-15 has decreased compared to the original standard. The design of the PL-15 originated from the LM-260 in the US PPT plan in the 21st century. As the predecessor of the PL-15, the PL-12 is China's first independently developed and commissioned fourth generation beyond visual range air-to-air missile. However, due to the era when the PL-12 was designed, China's technology in electronic equipment, missile materials, and rocket engine propellants was still somewhat behind the world's advanced level. So we can see that the equipment compartment, warhead, and even the radio fuse of the PL-12 designed at that time were particularly large. As a result, although the diameter and length of the PL-12 were larger than those of the US AIM-120 of the same period, its range was not as good as that of the US AIM-120 of the same period. By the time the PL-15 was designed, China had made significant progress in electronic equipment, radio fuses, missile materials, and rocket engine propellants. However, since it was targeting the AIM-260 in the US PPT at that time, and the design range of the AIM-260 in the PPT exceeded 250 kilometers. After China saw this information, great efforts were made in the PL-15 to achieve the range of the AIM-260 in the US PPT. The volume of the PL-15's seeker, equipment compartment, battery, and radio fuse was greatly reduced. So in this India-Pakistan air battle, we can see that the body of the PL-15 is quite long. Even so, the PL-15 at that time still couldn't reach the range of the AIM-260 in the US PPT. Therefore, when designing the PL-15, China made great efforts in the missile's body materials. The body of the PL-15 is basically made of composite materials. Moreover, to achieve the range of the AIM-260 in the US PPT, the PL-15 even adopted a higher smoke emission launch method, which is in sharp contrast to the smokeless launch air-to-air missiles in Europe and the US. As a result, the procurement price of China's early PL-15 was higher than that of the US AIM-120D of the same period. Even so, it still didn't reach the range of the AIM-260 in the US PPT. China then adopted a two-step approach to achieve or exceed the missile performance of the AIM-260 in the US PPT, which led to the next generation of the PL-15. Finally, the design range of the PL-15 was about 1.5 shorter than that of the AIM-260 in the US PPT. But when the PL-15 was commissioned, it was unexpected that the US AIM-260 became a disappointment. The US AIM-260 was delayed in commissioning. It wasn't until 2025 that photos of the US AIM-260 being flown on a Boeing 737 were exposed. From the exposed photos of the US AIM-260, the length of its seeker, equipment compartment, battery, and fuse is still much longer than that of the PL-15. Moreover, the AIM-260 has another problem. Due to the length limitations of the original F-22 and F-35 bomb bays, the length of the AIM-260 can only be maintained at around 3.65 meters, similar to that of the AIM-120. This is the so-called the ways of our ancestors cannot be changed. Japan also exposed the range of the US AIM-260. Although there are different range versions of the US AIM-120 and AIM-260 online, according to the information exposed by Japan, based on the original US military range standards, the range of the AIM-120D is only 111 kilometers, and the range of the AIM-260 is only 153 kilometers. In fact, the range of the AIM-260 that the US is still testing is far less than that of the PL-15, which was commissioned around 2015. Moreover, from the comparison chart, we can see that compared with fourth-generation air-to-air missiles from various countries around the world, the PL-15 has the shortest radar equipment, battery, and warhead fuse, while its fuel compartment is the longest among those of various countries in the world. The PL-15 was mainly developed to attack the US F-22 and F-35. Therefore, the PL-15 uses a gallium nitride-based phased array seeker and two-way data link correction. Among the air-to-air missiles commissioned around the same time as the PL-15, except for Israel's Derby-2, which uses a gallium nitride-based phased array seeker, Japan's AAM-4B only uses the previous generation of active phased array radar seekers. As for Europe's Meteor and the US AIM-120D, they still use flat plate slot radar seekers, which are at least 2 generations behind the PL-15. Additionally, the diameter of the PL-15 seeker is much larger than that of Israel's Derby. Therefore, the PL-15, with its active gallium nitride seeker, is unparalleled among air-to-air missiles available for purchase worldwide in terms of anti-jamming capability and terminal guidance range. Let's take a look at the technical level of air-to-air missiles from other countries around the world. First, the Meteor. The Meteor is quite different from most medium-range air-to-air missiles of other countries today, as it uses a solid fuel ramjet engine. The biggest problem is that with this solid fuel ramjet engine, the Meteor missile may experience engine shutdown when attacking targets at certain angles. Another major issue with the Meteor missile is that its seeker uses a flat plate slot Doppler radar seeker, which is relatively less advanced. Moreover, since the Meteor air-to-air missile was mainly developed by BAE Systems, France likes to go its own way. As a result, French fighter jets have a problem. Due to data link conflicts with the Meteor missile, Current French fighter jets are not fully compatible with the Meteor. Therefore, France faces great difficulties with the Meteor. In this recent air battle, the Indian Air Force has not yet equipped the Meteor and has to wait for France to resolve the data link issue. But as we saw earlier, although the Meteor Air 2 air missile uses a solid fuel ramjet engine and has a relatively long range, it may have the problem of missile shutdown when attacking maneuvering targets. Also, because the Meteor missile uses a solid fuel ramjet engine, it can only ignite at a certain speed, so its launch envelope is narrower than that of Air 2 air missiles using rocket engines. Air 2 air missiles using solid fuel ramjet engines can't be launched by aircraft under all conditions. They can only be launched under certain conditions. In air battles where the battlefield situation changes rapidly, using the Meteor Air 2 air missile for fighter 2 fighter combat is not very suitable. The Meteor Air 2 air missile is probably more suitable for attacking second-line early warning aircraft or aerial tankers. It's relatively less suitable for attacking fighter jets. Let's talk about Japan's AAM-4B. The AAM-4B Air 2 air missile is the world's first Air 2 air missile to use an active phased array radar seeker. However, because it appeared relatively early, as we can clearly see from this diagram, when Japan introduced the AAM-4B, it uses a dual thrust solid rocket engine for propulsion. What's the difference between dual thrust and dual pulse air 2 air missiles? In fact, the big difference is that compared with dual pulse, the dual thrust solid rocket engine achieves different speeds in the front and rear phases by using different fuel compositions in the front and rear parts, thereby extending the range of the Air 2 air missile. But its disadvantage is that the dual thrust rocket engine can't ignite a second time. Like traditional rocket engines, it burns all the fuel at once. Therefore, in terms of maximum range, it's actually not as good as dual pulse air 2 air missiles. Let's look at Israel's latest Darby 2. In fact, this Air 2 air missile was launched around the same time as China's PL-15. The Darby Air 2 air missile also uses a semi-mounted active phased array radar and a dual-pulse solid rocket engine. However, Israel took a shortcut, and its surrounding opponents are relatively weak. So Israel's Darby Air 2 air missile actually only replaced the seeker of the Python Air 2 air missile, and its main structure still uses that of the Python Air 2 air missile. So we can see that the Darby Air 2 air missile has a diameter of only 16 centimeters, a length of only 3.6 meters, and is very light, weighing only 122 kilograms. Therefore, although the Darby uses a dual pulse rocket engine system, its range is only 100 kilometers. Moreover, although Israel's Darby uses a data link, not all countries' aircraft use Israel's data link. So if you want to equip the Darby Air 2 air missile and especially wanted to utilize the data link, either the country that originally developed the fighter jet is willing to open its aircraft's fire control system to integrate the data link of Israel's Darby Air 2 air missile into its fire control system, or Israel has the ability to hack into the other party's fire control system, which Israel doesn't have. This is actually a major issue. Our new PL-12's equipment compartment is much better than that of the early PL-12. But does this mean that the PL-15 is the most advanced Air 2 air missile in the world? In fact, according to the latest exposed pictures, the PL-16, which is paired with the J-35 and J-20S generation of aircraft, has seen a significant increase in range through a new launch mode compared to the PL-15, exceeding 270 kilometers.